Okay, so welcome back to our discussion. So we have here another sample problem involving a 2 wattmeter method. Okay, so we know that in 2 wattmeter method, so the load is connected in delta, or if that is in Y, we transform that to delta and then use the 2 wattmeter technique. Okay, so for our sample problem, so suppose the 2 wattmeter method was used and the 2 meter reads 150 and 2000 watt, 100 watts respectively. If the line voltage is 220 volts, so find the per phase average power, the complex power per phase, the power factor, and the load impedance. Okay, so how do we solve that? So to solve for the for PPA, for the per phase average power, we need to solve first for our total power PT. Okay, so PT is simply equal to the reading in the first meter plus the reading in the second meter. And that's equal to 1,560 plus 2,100 watts. Okay. So what will happen next? So adding this two will give us 3,660 watts. Okay. So we're asked to find PPA. So how do we solve for PPA? We have 3 phase. So if you have 3 phase, therefore we're going to divide this by 3. So dividing that by 3 would give us the per phase average power. So that would be 3,660 over the phase. So 3 phase, so that would be 3. So the answer would be 1,220 watts. So that would be the per phase average power. Okay. So do you have any problems or questions towards this one? So we already now have this. So we have already solved this. Now let's solve for QP. So we know that I've given the concept part of our lecture that QP is equal to square root of 3 P2 minus P1, or rather QT, not QP, okay? So this should be QT, not QP. So QT is equal to square root of 3, so P2 is equal to 2,100 minus P1 is equals to 1,560 watts. So solving for our QT, so that would lead to okay, 935.3 VAR. So we now have our QT. So we need to find our per phase reactive power. Okay, so how do we solve that? So to solve for the per phase reactive power, so that is simply equal to QT over the number of phase, which is equal to 3. So that would be 935.3 over 3. And that will give us 311.77 VAR. And that is our per phase reactive power. Okay, what's next? We need to solve for the power factor. Okay, so recalling how we solve power triangles. So how do we solve power triangles? So suppose we draw again a triangle here. So hindi ko kabisado yung sulat kasi nung sa camera ko. So mamaya kasi bilang mo ba, hindi na makita yung sulat ko. So dito yung real power or P na lang. Okay, pakita tayo dito. So dito si real power. Dito si reactive power Q. At ito si apparent power S. Diba nga? Okay, so going to the picture na bigay sa inyo, para matandaan nyo to. So, okay, so just look in the group chat. Okay. So, basahin namin na yun. Q is VAR. P is watts. S is VA. Okay. Yan. So, paano natin ngayon i-solve yan? So, power factor, we know that power factor, PF, is equal to what? Power factor is cosine theta. Is So what is our QT? So QT, PT, ST, yan ito consider natin. QT is 935.3 VAR. Actually, we have two solutions for here. So bahala kayo kung anong mas komportable sa inyo. So 935 VAR yung QT. Ano pa meron tayo? Meron tayong PT equal to 3,660 watts. Alam natin na watts yung dalawang yan. At iba lang tayo dun sa kanilang nire-represent na power. Okay. So, considering cosine theta, trigonometry, we know that cosine theta is what? Adjacent over hypotenuse. Wala tayong hypotenuse. So, how do you find hypotenuse? So, we have two solutions. So, una-una, nakita nyo right triangle yan. We can simply use Pythagorean theorem. Diba? So, may Pythagorean theorem. Makukuha natin yung hypotenuse. So, that would be equal to 1, so that is 3,660. Quantity squared, yung ating PT plus yung ating QT, which is square of 935.3 squared. And we can also solve our ST. So our ST now would then be equal to, pag solve natin yan, so that would be 3,777.66 VA. So nasolve na natin ngayon yung ating ST. Okay? So now we have ST, we can find cosine theta. So cosine theta, okay, adjacent side is 3,660 over this 377.66. And that would give us the power factor equal to 0.9689. So, 0.9689 yung sagot dyan. Nakikita ka. Guys, mo ito ulit. So, 0.9689. Ating power factor. Okay. So, another approach for that is if you use tangent theta, okay, makuha din natin siya. Okay. So ang phase angle, importante rin yan ngayon para sa next problem natin. Okay. So, may QP na, may PF na, si ZP ngayon ang problema natin. Ang ZP ay equal siya sa ZP angle bar of theta. Okay. Pero yung ZP natin, kailangan mo natin siyang isolve. So, how do you solve for ZP? So that would be yung phase voltage over the phase current IP. Okay, so now, how do we solve that? So wala pa tayong IP, so we need to solve for our IP first. Okay. Recall that if that would be delta connected, that means VL is equals to VP. Okay. Alam naman natin yan na equal yung dalawang yan. So therefore, wala tayong problema sa numerator. Ang problema natin si IP. So we can equate that rather, and we know that the per phase power is equals to VP, IP, cosine of theta, or that would be VP IP times the power factor. Okay. So to solve for that, okay, we know the power factor is 0.9689. So we simply substitute the value. Alam natin yung per phase power, yes or no? Yes, alam natin, na 1,220 watts yan. Okay. So we inject all the values such that we can solve for our IP by cross multiplication and introduction to the other side, manipulating this equation. So that IP now would then be equal to the per phase power over the phase voltage 220. Saan na yun? Ito. Multiplied by cosine theta, which is our power factor. So IP now would then be equal equal to, okay, so by calculating, we can resolve as 5.723 amps. Kita pa naman siya. Okay, I'm running out of space. Now, may IP na, may VP na, yung phase angle theta. So sabi ko, pwede natin gamitin kanina si tangent theta. Okay. So if we use tangent theta, we can solve for that. So by using tangent theta, so pag ginamit natin sa tangent theta, so that is this one over this one. So that is 935.3 over 3660 watts, diba? And theta would be our tangent of this, okay? Which will lead us to have a value of 14.33. So, ayan. So, paano kukuhin to? So, inverse lang natin yung tangent dyan. So, ngayon makukuha natin yung meron tayong theta dito. So that we can now rewrite this full equation as 2,000 or 220 over 5.723 angle bar of 14.33. And that will lead us to the value of 38.44 ohms. So that is 38.44 ohms. Which is our CP. So ito na siya. Ngayon. So do you have any problems or questions with regards to the sample problem? So this concludes our module. Okay, so keep on practicing with the problems. Okay, keep on answering your modules, the PPT sheets. It will help you for your long exams. Okay. So if you have any problems, you have clarifications with regards to this discussion or this lecture, don't hesitate to send a private message. Sir Gian is always here to answer your questions.